yeah, in India, it is still a budding industry, right? Previously, I mean, it was mainly dominant by the Flipkart, Snapdeal, then Amazon came, right, and then Walmart acquired Flipkart, right, and so on, right. So this started happening. And when we talk about the small and medium businesses, they always prefer to go via these big channels, right? I mean, they host their products in Amazon, they list it there, and from there it is actually sold, right? Yeah, so thanks for one example, right? So Bombay Troopers, then there's KRA, then there is Gamboy, right? So these are the various companies that you will come across recently, right? In the Instagram, if you follow, and you'll be bombarded with those ads there, right? So this particular talk is focused for those companies, right, the small and medium businesses in the e-commerce side who are trying to make their name in this domain, right, and want to make it big. Uh, and there is a certain challenge, right, in the e-commerce sector when we talk about it, right, that is everybody wants to generate more and more revenue, right, and how to do that? It's about how can you convert your incoming users more and more, right? If you do that properly, efficiently, with optimization, then you will be prospering as a good business, right? If you can't do that, then you are going to just disappear in the flow of time, right? So yeah, so this is us, Abir and I. So we have actually structured this talk into this steps, right? So first we are going to talk about what exactly is the problem statement, right? Which the current SMBs in the e-commerce sector, not only in India but worldwide, are currently facing, right? How the big companies are having that advantage, right, over those companies. The existing approach with which the big companies are currently operating, right, and the mid-sized segments also operating in that particular fashion. The problem with that, and why we need that Pybandit approach, right? So that is the crux of our talk, right? So we are going to spend most time in that, and then what is the main difference, the advantage of Pybandit, and then we're going to show a demo, and then we're going to conclude, right? So that you know that what is going to come next, right? So let's talk about the problem statement, right? So if you are into the e-commerce domain, right, you got to spend a lot of money, right, in the advertisement purposes, right? And most of the digital spend actually happens in the social media setup, right? So 80% of your spend are happening on the Facebook, the Instagram, the Googles of the world, right? And what happens is, as you are spending this money on the advertisements, so you are expecting more and more users, right, coming to your website, right? But what happens is, what after that? Bringing the customers or users to your website is not enough, right? You have to make them buy at the end of the day, right, to realize the revenue. So if we look at the offline store and compare it with the online store, right? So offline store is the brick and mortar store where you have the actual physical stores, right? And then people are going, I mean, people are actually receiving you, they're actually helping you to figure out, I mean, what to buy, what not to buy, talking about the features and all, right? So if you look at the conversion rate, right, more than 20% is the conversion rate for the brick and mortar. While in the e-commerce sector, for the same company in the web store, right, if you look at it, it is less than 2%, right? And why is that? So if you look at a particular web store, for example, let's say Spar hypermarket. So we are in Bangalore, so let's talk about a Spar hypermarket. It is, I mean, I can bet every month if you visit, the whole, I mean, setup, right, where the shelves were put, right, where the products were listed, right, I mean, they were actually kept, that is going to change every month, if not weeks, right? Because the facility manager notices, observes that which users are coming at which time, are focused on which products, right? And based on that, they continuously, I mean, upgrade and update whatever is the structure that they have, right? But if you look at the e-commerce web store, right, that doesn't happen like that, right? Once you create a website, you have figured out that how to list a product. You keep on listing the product. You sometimes, I mean, change the image. Sometimes you modify the content or the price depending on the socioeconomic conditions, and that's it, right? You don't spend as much effort as a facility manager spends on a brick and mortar shop, right? On the web store. So how can you actually beat that, right? So you are not taking care of your digital web store as much as a facility manager does it for the brick and mortar store. So this is a typical setup through which a customer comes to a website for an e-commerce web store, and finally they gets converted, right? So you see that blue person. That blue person came because they actually saw some ad in either Facebook or Google or Instagram, or they knew about this before, or they came to know about from friends and families, and then they have reached there, right? The whole purpose is how we can make it go through this whole funnel and go out, right? To give $1 for the company. So first they come to the homepage. If they like what is being offered in the homepage, so how do they know? They look at the messaging, what is written. They look at the design, whether it is looking legitimate or not, right? Which is very subjective in nature. And if they find something useful in the homepage, they go to that particular product. They go to the product, look at the description, look at the reviews, then look at the price, whether it is something that he can actually go for or not. Then if he likes it, adds it to cart, finally checks out, payment is done, right? But as I told, contrary to the brick and mortar shop, this website, right, is not regularly updated, right? And that's why it gives, it results into an ineffective store. And that's why the conversion is pretty low. Now, as we are talking about the pandemic era or post-pandemic era, still hazy, right? We are not sure when COVID is coming back. So digital is still at its peak, I would say. If not, it is going to get better over days. So the consumers, right? We all like to go digital now, right? So of course, the population is coming back to the offline setup, right? But still, the preference is ordering it online, getting delivered, leave at doorstep, don't touch me, right? Don't talk to me, that sort of setup, right? So brick and mortar stores are also adapting to this new thing, right? And given the socio-economic condition, what is happening throughout the world, with all the conflicts going on, the economy is at stress, so the marketing budget is also squeezed, right? So this is the challenges that we currently have, right? And how the big companies are beating it, right? Big companies are having an edge over the small and medium businesses. So this is a typical customer funnel for any e-commerce company, right? So first we have the impressions. That is how many people actually ended up coming to your website, right? Then eventually they choose to stay on the homepage. If they like, go to product. If they intend to buy it, add it to cart. And finally, they goes for checkout and payment is done. And finally, it is a conversion, right? So that's how typically done. And you look at it as a funnel because every stage users are churning out, right? So there are people who came, didn't like the homepage, they churned out from there. They came to homepage, didn't find the useful product, they churned out from homepage, and so on, right? So if you look at how the big e-commerce companies are falling into this setup, is the Google, Instagram, and Facebook of the world are giving the impressions for any website, right? So you host that ad, and they have very sophisticated, user-centric, user-driven algorithms, right? Which actually keeps track of their search history, their usage pattern, right? They figure out their age group because you fill out the user info and all those things, right? So they segment the users based on that. They identify the behavior, and based on that, they actually show these ads, right? Which will be very specific and targeted for those customers, which is actually using the Google, Facebook, Instagram, right? Now, once they come to the homepage, right, then all that brain, all that, techniques, sophisticated algorithms, that actually goes away, right? Because now the user is at the homepage where it is your domain, right? It is your control now. So homepage, product page, cart page, checkout, and payment page is actually handled by the big e-commerce companies, for example, Amazon or eBay, right? So starting from coming, they actually track you, which products you are visiting, how many times you are spending, which reviews you are interested in, whether you have been a previous user or a customer of that particular setup, right? All that information they already have. And even for the anonymous users, right? So they first actually ask you to sign up, and depending on the limited user history, they actually try to map you where they would fit so that they can show you the right pricing, the right messaging, and the right design for certain things so that you convert better, right? So that's how it is done, right? So homepage, product page, cart page, and checkout page is completely in control of Amazon and eBay, right? If you look at small and medium businesses, they don't have an army of full stack engineers or website developers or anything, right? So how would they do? For the impressions, they're still dependent on the Google, Facebook, and Instagram, right? But the checkout and the payment and hosting the website, right? These are the things some of the companies has made it easier for them. For example, Shopify, BigCommerce, WooCommerce, right? So that's why Shopify and BigCommerce is giving them a platform where you can actually go and upload a picture of the product, set the price, set what design you want to choose from the catalogs or the theme libraries that they're having, right? And based on that, it is making very easier for you, even if you don't have any knowledge of the development of full stack setup, right? You can easily create a website, you can actually set up your payment page, you can link your bank account, everything is done, right? And because of that, you have very less flexibility, right, into the homepage, product page, cart page, right? You can't do, dynamic changes, right, over time that the army of the data scientists and the machine learning engineers, which is there in the Amazon, eBay, right, they are doing. All those things actually goes away, right? So though you are using the same medium to get your users to your website, but you are not able to actually convert them because you are not nurturing them, you are not properly guiding them through the journey on your website, right? So that is the reason the Pybandit is here, right? So Pybandit is actually focusing on this mid of the funnel, that is the homepage, product page, and the cart page, right? And it focuses on the small and medium businesses users, right? Which is not in lakhs or not in millions, right? If you look at Amazon, they have millions of users coming every day on their website. But in small and medium businesses, they have hardly 20, 25 products, right? 20, 25 SKUs in their website. And it is hardly 5,000 to 10,000 impressions they are getting on their website, right? So all the sophisticated algorithms that Amazon, eBay, Flipkart, Walmart, they're having is actually ineffective because those algorithms are suitable for high traffic, high volume users, right? And that is why the Pybandit is here to rescue, and it helps you to do three things, right? It helps you to choose which design is going to resonate well with your customers, which messaging is going to make the customers feel like they want to buy from your website. And it gives you a way to manipulate the pricing part, right? So you can actually do something like this, right? That is, you are trying to set the price of a particular product at, let's say, 100 rupees, right? You can say that, well, the price is 200 rupees and I'm giving 50% discount, right? Or you can say that, well, it is just 100 rupees and no discount is available, right? For both of the cases, right, you are actually pricing it at 100 rupees. In some cases, you are showing discount, some of the cases it is not, right? And depending on the people's psychology, people's user behavior, people's past history, how they actually interacted, they actually tend to select one over the another, right? Depending on the nature of the people, right, that is coming to the website. So in the next one, I would ask Abid to actually talk through the existing approach that we have for the high volume traffics, right? And how that is actually in play. It is not a bad approach. We will actually discuss how it is not suitable for the low volume traffic for the small and medium businesses in the e-commerce sector. All right, so Abid, off to you.
Thanks, Tuhin. Hello, everyone. So, first of all, let us see how the big companies are tackling the situation. Here, we have a website with us that makes customized gifts for your friends, families, and loved ones. So the store manager, the marketing research team wants to try out 4 different variations for their homepage, like find a gift for your wife, find a gift for your girlfriend, find a gift for your better up, and he wants to find which variation actually is resonating well with their consumers. So what he does, he actually evenly distribute the incoming traffics into 4 equal hubs. Here we have 4 different variation. So he distributes the whole traffic into 4 different hubs, 4 equal hubs, and shows these variations to each part of them. And he notes how many of them is actually ending up buying that product, is that if it is actually conversion or not. After running this whole process for 3 weeks, he notices that the third variation is actually enjoying 4% conversion, which is the winner. And why is that happening? Actually, what happens? Bachelors are actually visiting the homepage and making the most of the purchases. So that's why he finds out the third variation is actually winner, and third variation is actually drawing more and more conversion, and that's why he only keeps the third variation, and removes all other variations, and targets the whole traffic towards that third variation. But there is some disadvantages of this existing approach, and why we can't use this approach to small SMBs. Like, first of all, for the SMBs, there is low traffic. Like they enjoy only 5 to 10,000 footfall every month, and it becomes problematic to explore all the variations and to get a statistically significant result or statistically significant winner. Second of all, only 25% of the potential customer gets to see the superior variation, and rest 75% potential customer misses out and gets to see the inferior variation. As a result, the conversion rate gets lower. Third of all, these SMBs are actually fast moving in nature. Like, they try to add different products every day. They try it out different designs, and for that you have to ditch out the past experiments and restart the whole experiment from scratch, and that is not possible for them. But actually they can't afford the sequential experiments. That's why we introduced Pybandit as a rescue. Pybandit is there to rescue. So what happens in Pybandit? Here is no hard and fast allocation rules. Like, we have to allocate 25% traffic, 30% traffic to first variation, 40% traffic to second variation. Everything happens real time. Here what happens? Every time a consumer is visiting the home page, biased coin is tossed, and if it's turns head, then the customer is shown a random variation. But if it lands on tail, then on the past till the past events, whichever variation is working best, or whichever variation has the highest conversion, it is shown to that customer. Here what happens? You get to explore, like, all the variations. You get to explore all the variations, as well as you can exploit them as well. And as a result, after running the process for 3 weeks, you get to see that whichever version is superior, is that here in this case the third version is superior, enjoys a higher traffic than the existing approach, and higher the traffic, higher the conversion rate, as simple as that. So as a result, here the traffic is almost 76% total traffic, and it is enjoying almost 4.3% conversion rate. Then what happens? Until the 100% traffic is converted, 100% traffic is targeted towards the superior variation, Pybandit works. Pybandit works till 100% of the traffic is directed towards the superior variation. And then, now let's see what's the main difference between A/B testing and multi-armed bandit. Is that the Pybandit. Here on the x-axis you will see the week, you can see the weeks, and on the y-axis you will see the actually number portion of population is enjoying, is get to see the variations. Now what happens in A/B testing, till 6 weeks every variation gets to enjoy 33% of the population. After 6 weeks, when the A/B testing is done, we will know the which variation is best, and whole traffic will converted toward that whole traffic will be in the superior variation. And on the other side, in MAB, multi-armed bandit, as time goes, the population is directed towards the better variation over time. And end of the day, end of that 6 week, we will get to see that the population proportion of the population that is targeted with the higher based variation is way more than the A/B testing. As a result, you will get to see higher variations, higher conversion rate. And let's talk about advantages of Pybandit. Well, for Pybandit, as the variations get higher impressions, we will get to see the higher conversion rate. Here, almost 70% guess, 70% traffic is targeted, is directed toward the variation. But here during the exploration phase, when the Pybandit doesn't know what is the best variation, till then it is converting, it is directing 70% of the population, 70% of the consumer towards the better variation. But in the existing approach, only 25% of the consumer is getting to see the better variation, as well as the conversion rate is also low. Here we can see that the Pybandit approach enjoys 20% more variation, 20% more conversion than existing approach. Now imagine for each conversion you get to enjoy $100 revenue. Then what will happen? If you use Pybandit, you will end up enjoying 54,000 more revenue than our existing approach. Secondly, Pybandit automatically detects when the exploration phase is done. Not like existing approach. Whenever the exploration is done, you need a statistician to tell if the result is statistically significant or not. Then it will take time to actually implement with the market, with their team, to exploit that result and target the traffic towards that best variation. But in Pybandit, what happens? It automatically takes care of everything. It automatically exploits the whole consumers, and end of the day, it directs whole consumers towards that base variation. And as Pybandit supports dynamic multivariate testing, you don't need to stop, or you don't need to ditch out your previous process. Just suppose after third week, after 3 or 4 days, your UX team decides to try out a new design, or your UX team wants to remove a new design. If you were using the existing approach, you have to ditch out the past process and restart the whole process over again. But in Pybandit, you don't need to end up your process. You can actually add or remove anytime anything, and your experiments will continue. Next, I will like to ask Tuhin for a demo.
Yeah. All right.
Thank you.
Thank you, Abir. So we have actually kept some good amount of time for the demo, right, and for the Q&A, right? So one of the main reasons for this talk was not only to raise the awareness of how it is important and how much it is important for the small and medium businesses to actually fight this battle with the existing big companies, right? But also have this tool, right, for everybody's, everybody's there to use it, right? So if you look at the machine learning domain or the deep learning domain, so we have quite a few open source tools, right? I mean, so in the case of machine learning, you have the libraries like scikit-learn, right? In case of deep learning, you have TensorFlow, Keras, then PyTorch, and all those things, right? But in case of the multi-bandit algorithms, right, you don't have any such libraries, right, because this is not, I would say, it is not very easy to implement. It is not very easy to understand as well, right? And as he actually showed, right, that is, people are really afraid of doing experimentations, right? Because the term experimentation itself has that uncertainty inside it, right? That is, when you think about experimentation, something could go wrong, right? That's how the experiments are, right? And the small and medium business companies, their founders are probably supply chain managers, some product owners, right? They're really afraid of all these things, right? So how can we democratize this particular idea, right? This idea is not something groundbreaking, or it was not there, right? So it was already there, but nobody was actually talking about it, right, in the small and medium businesses sector, right? So how can we make this available for those companies, right? Is one of the main motivations behind us coming in front of you, right? So the demo will start, but before that, I would just like to tell you that we have a Pybandit package in the PyPy, right? So you can just go ahead and do pip install Pybandit. It will install that package. Of course, it is not a great package at this moment of time. So you can see on the right-hand side, we have a roadmap. So we started with Epsilon Bandit. It is highly technical in nature, so I'm not going to go deep into those, right? But this is the roadmap. So we start with the Epsilon Bandit. We're going to implement those algorithms. So we're going to make them part of this, right? So at the end of the day, we want to create a scikit-learn for multi-bandit algorithms, right? And for that, we need volunteers, right? So if any of you are interested in Python, writing Python libraries, right? It doesn't matter whether you're good at statistics or not, feel free to join, right? We could use all the help that is there. And eventually, we can go for the Bayesian bandit, contextual bandit, dwelling bandit, and these are different types of multi-bandit algorithms that is there, where a lot of research has been done. And that is how all the other open source tools are also created, right? So those tools are not invented by them, right? So those tools are created by assembling all the existing research papers that was published, right? And then a good sort of development skill set required to kind of implement those things in a really good amount of time complexity and space complexity manners, right? So let's go to the demo, right? So here what we have done is we have created a simulation, right? So as you can see here, the first cell is useless. We just, import some utility libraries. The second cell you'll see, that is where we are importing Pybandit, and if you install that Pybandit package, this package you can actually import and you can use it, right? So one of the algorithms that has been done there already and is available, it is 0.0.1 version, right? So I started it around 2 years back, right? And due to all those COVID challenges, I didn't get to implement it at full speed, right? But now I would like to take your help if you're interested in joining, right? So feel free to DM me, and I'll add you to the community, right? And so in this case, you are seeing that first we are setting up a simulation, right? So for example, you see here the n arms is there, which is 4, right? So even if you don't know about Python, it's quite fine, right? So I'm just going to categorically tell what each of those lines are so that you get a feel of how this operates, right? So the number of arms is the number of variations that we had, right? So we had 4 variations, V1, V2, V3, V4, right? Epsilon is that biased coin that he talked, right? So we have a biased coin which has a 0.1 probability of turning head and 0.9 probability of turning tail, right? So if head is coming, right, then we are giving all the variations equal chance, right? So if a user comes, then from a uniform distribution, one arm will be drawn, and that particular variation will be shown, right, to the user. What happens when the tail comes, right? So 90% chance is the toss will be a tail, right? In that case, at that moment of time, right? So let's say till that time, 100 users has been actually shown a variation, and we also recorded what is the conversion of those variations, right? So at that point of time, it could be V2 which is performing the best, right, at that moment of time. So we just recommend V2 to the new user, right? So that's what the Epsilon does it here, right? Draw count list is where we are keeping track of how many people are shown individual variations, right? So that's why we have a list of 4, right, equals to a total number of variations or the arms. And then we also record the conversion rate, right, at a particular point in time. What is the conversion rate for those 4 versions, right? So based on that, we'll choose at a point of time which one is the best, right? So with 90% probability, we'll just show the best variation to that particular user, right? So that's how it works. Now, we also need to create, so this draw arm and update draw count conversion rate, these 2 functions are just external functions to simulate the response of the users as they visit individual variations, right? So draw arm is what are the chances that if a particular user sees a variation, let's say V1, what are the chances that that particular user is going to convert, right? So that's what the draw arm is going to actually give you, right? So, and after that, the update draw count and conversion rate is at a particular point of time. It just captures the snapshot of the current existing setup, right? That is, this many number of users has come. These are the 4 variations. 100 saw the V1, 200 saw V2, and so on. And this is a list of the conversion rate at this moment of time, right? That's how it is done. So how we do it first is we first initialize epsilon greedy experiment, right? Where it is just an instance of the epsilon greedy algorithm that we have implemented for the first, right? So where we initialize that, we say that there are 4 variations, total number of arms. I'm saying that 10% of the times I'm going to randomly show a variation. 90% of the time I'm going to show you the best performing variation at that particular time, right? And then we initialize the how many times each variation is shown to the users and what is the conversion rate for individual variations at that particular point of time, right? So that's how this particular cell does. This cell is where we initialize the true reward probability. That is not supposed to be known by the system, right? That is the intrinsic true probability with which the individual variations are going to convert the customers, right? Which is not known to the system, right? So that's why reward probability list is something that is not supplied to the epsilon greedy experiment, right? So we are supposed to estimate the reward probability list, right, for each of those variations, right? So what we are going to do, what that draw arm is going to do is it is going to take one, the true conversion rate for each of the variations, and based on that, it is just going to throw whether it is a convert or no convert, right? And based on those outputs, this experiment is going to estimate what is the true conversion rate of those variations, right? So that's how it is done, right? So let's say for the first, we actually set it at, and let's do as 34 is there, 32, let's say, right? And we just run this experiment. We start and run all. And what we are going to see is this iteration ID that you are seeing, right? It is real time happening, right? So this is how actually the users actually come to the website, right? So around 4,000 users already came, and then you see the selection method. It actually either it will be exploit or it will be explode, right? Then you will see the number of times they're drawn, right? So how many times the V1 was actually drawn almost now, I think 70, 80% of the time V1 is drawn, right? And their conversion rate here, this is actually the estimated conversion rate that we are actually deriving, right, from the true conversion rate, right? So if you look at the true conversion rate, which is 0.34, 0.30, 0.24, 0.32, it is kind of, reaching towards that, right? So, so actually, the first is clearly the winner, right? And most of the population, right, most of the users actually drawn towards that, right, in that case. Now let's say you run it for a week and you decide that, well, the third variation is not performing really well and I want to put a new variation with new message, right, and which actually is very good one, right, which was not actually very common till now, and people actually started liking it. So let's say we assign that with, let's say, 52% intrinsic probability rate, right? And again, this is not known to the system, right? So this is an outside variable, right? Based on which the pages are going to get converted, right? So we replace that third variation, right? And we, with a new variation, right? And which has a true probability of conversion of 0.52. So now let's see what happens if we just, resume that, right? So the total number of things that you see, that is, it's still the same experiment that is going on, right? So 31,000 is actually going to the first variation, right? So gradually, if you see that the third variation is actually started to increase, right? So 0.31 now, 0.32. First variation is still stuck at the first point, right? 0.35, right? Which is the true probability already it has reached. The third probability is actually gaining a bit of momentum. And let's see what happens when it just touches 3.5. Yeah, see, it just shorts up from there, right? Because just after that, those 90% of the times, right, when you cause that biased coin, right, the base variation is not V1 anymore, right? The base variation is V3, and that's why it just shoots up, right? And it goes there near 0.52 and kind of stabilizes there, right? Yeah, so this is some, wow, okay. So, okay, so, but anyway, so you got the idea, right? So some, I think the space exceeded error, yeah, rate limit exceeded error, yeah, that's fine. But you got that idea, right? That is, at any point of time, you can actually choose to use a variation, remove variation, change variation, delete variation, right? And still, it is going to hold the end result of the experiment, right? Because we started with this reward probability list, right? That is so that we know that whether it is actually following the actual true conversion rates or not, right? And that's why we set it out, right? So that we can see that how close the estimation of the Pybandit is with the real values, right? So I think this is it.